Hello and welcome to Team 1's Gait Review 2 for the multi-terrain therapy treadmill. I'm Derek Elam.
Tyler Nolan.
Here's O'Rainer.
Jacob Rourke.
And Tyson Burton.
Once again, thank you for joining us today for our Gait Review 2 for the multi-terrain therapy treadmill. Today, we're excited to take you through our work thus far on this project. We'll start with having D'Angelo take us through a project recap of work done up to Gait Review 1. After that, the rest of the presentation will be broken into three main parts. We'll be using this story map to help guide us through these parts. We will begin with having Jacob take us through the concept brainstorming phase. Here he will describe the evolution of our design space and how we use that to create multiple design concepts. We will then take those design concepts into the design selection phase. Here, Derek will explain how we evaluated these designs to get down to the three we have to present to the client today. I will then talk to us about our material selection process and how we use interaction with the client to make informed material selections. We will then be able to move into our design analysis phase, where Tyson will describe how we analyzed our three designs to be better informed on these designs and to better inform the client of potential failure modes that they need to look out for in these designs and how we look to mitigate those and work against those. Also in this phase, we'll be able to present today our top three design ideas for the client to choose from for the team to move forward with. We have the retrofitted woodway design, tiled treadmill design, and we'd also like today to present the possibility of a custom-built treadmill design built exactly to NeuroHope's specifications. We'll get more into the details of those designs later. We'll also be talking about our testing plans for each of these designs and what work we hope to do in the future. And at the very end of our presentation, we will be opening up to discussion with the client and the possibility for them to make a selection for the team to move forward with. Without further ado, let's hand it off to D'Angelo to give us a project recap.
So to recap what we've done from Gait Review 1, our project is to create a multi-terrain therapy treadmill or retrofit one for non-for-profit physical therapy rehab center NeuroHope. We gathered requirements and constraints that were through client interviews and various Scrum activities where we looked at what was really the most important. Some requirements that we gathered that were very important were having 2 to 3 exchangeable treads that could be changed rather quickly and simple. We're looking at 15 to 20 minutes for that. And some key constraints are having a $3,000 budget and fitting the Lightgate system, which has specific dimensions on the treadmill we want. We define success by limiting how many therapists NeuroHope needs. As you can see to the picture to the right, there's a lot of therapists. We want to limit that down as small as possible as we can, and we're aiming to deliver this by May 1st. So I'm going to hand this off to Jacob, where he's going to describe our concept brainstorming from these constraints.
Thank you, D'Angelo. So from the key constraints and requirements we gathered from Gait Review 1, we put these into a concept brainstorming area to make morphological analyses. So in our first morphological analysis, we had several functions and then means to fit these functions. So if you look into the highlighted areas on both of these design alternatives at motor placement, in design alternative 1, you will see that the motor placement is in front of the treadmill. And then in design alternative 5, our motor placement is in the middle of the treadmill. This would allow for us to make changes to the treadmill and then come up with many different design alternatives. So in our first morphological analysis, there were some problems with it for the fact that we were having the idea of retrofitting in mind instead of building a treadmill. And so the reason that this was a problem was because we were retrofitting to one certain type of treadmill instead of taking into account that there are many different types of treadmills that we can retrofit. And then also around this time, we got our hands on a cheap treadmill, and we were able to tinker with this, tear it down, and then also learn how the treadmill works and get a better understanding on what we need to do to retrofit a treadmill. So on our morphological analysis, or on our second morphological analysis from the stuff we just went over, we took and we gathered more functionalities that we could put into this. So from the treadmill that we tore down, and we figured out that there's actually material selection for a tread base, which is highlighted here. We didn't realize that there was more than one type of material that we could use. So in this, you can see we have medium density fiberboard and a hardwood that could go into this treadmill. Something that we kind of lost through this though was each of these design alternatives would be key to one certain type of treadmill. So each design alternative would be specific to a different treadmill, and they won't be able to transfer through treadmills. And then from that, we got 9 design alternatives to put us into our design selections.
So now we're going to take our 9 design concepts and we're going to put this through design selection and through decision matrices. And our first decision matrix was we benchmarked ourselves against a loco station woodway. But as you can see by our key criteria, we have tread types, speed of replacement, and ease of replacement. All of these correlating to replacing a treadmill or a tread on a treadmill. And of course, our benchmark doesn't do this at all. So our totals are going to all be relatively the same compared with our designs. So this was ineffective. So we go to our next slide and we have our second decision matrix. And as a team, we decided we were going to compare ourselves to one of our own designs, the design that we believed was the best. And as you can see, in the best design was the Velcro woodway that we came up with. And as you can see, the totals at the bottom, we start getting a lot more variation in our totals with tread types, speed of replacement, ease of replacement. And we can use this to extrapolate our top five designs. So we take our first 5 design concepts and then we go through some iteration and research and a cause and effect diagram, which is our quality function deployment. And this allows us to take a deeper look into some pieces of the treadmill and weigh pros and cons of different types and different functionalities in our treadmill. And we were talking with our lab manager, James Emery, and a little bit more research. And another one of our ideas that came from this was a custom treadmill that would allow for a custom tread width and a custom overall treadmill like width. And then this would eliminate many of the negatives from our cause and effect diagram. So going into our next decision matrix, we see that the functional project requirements on the left, such as simple mechanism to remove and replace tread width is 20 inches, and longevity. And we see our top 3 designs highlighted in green and the relative rankings at the bottom. So we have the woodway Velcro, the custom treadmill, and the traditional Velcro. And the woodway slatted is highlighted in yellow because that kind of piggybacks off of the other woodway design. So we wanted to have 3 different alternatives. So using these 3 now that we have our 3 designs, there's one more thing before we go into our design analysis, and that would be material selection.
So yes, like Derek said, now that we have our 3 designs, we had one thing left to do before we could move on to our design analysis, and that was material selection. We had the opportunity of meeting with Mr. Bart Richrowski and his colleague, Mr. Barry Moore from NeuroHope, to allow the team to get a better understanding of what material properties are important to them and their therapy strategies. We were able to ask them about what kind of properties of turf they would like to have to make their therapy and rehabilitation process as efficient as possible. And they explained that the most important property was the turf length. You can see here there's obviously many different turf lengths ranging from a speed turf at the bottom to a track turf or a more traditional lawn turf that would replicate something you see in real life. They described to us that the length of the individual grass blades were important because the longer those blades were, the more challenge it would put on the user to put their ankle into dorsiflexion as to not drag their toe across the surface. They wanted to challenge their trainees in this because they wanted to have them realize what it's like walking in the real world and to practice walking in that grass surface so that they don't trip if they're going out to walk in the real world. When we looked into a foam material, it was a little more complicated. They explained to us that they needed the foam to compress a certain amount to provide levels of instability that allowed for the user to be working on their balance and ankle stability muscles, but that compression can't be so much that their foot compresses all the way down to the flat surface and mitigating this response. So we were able to take this information and go and meet with our FTC, Dr. Sakib, and he was able to give us more information on how we can perform mathematical analysis to find materials that will give NeuroHope the properties that they need. We're looking more into these foam properties, and this is something we look to do more research on in the future to find the exact foam that we think will give NeuroHope the most effective therapy practice on our treadmill design. So with this out of the way, we can now move into design analysis, which Tyson is going to take us through.
So from our design selection phase, where we went through reduction of concepts and selection of our top 3 designs, this allowed us to then begin to consider different things that go into the analysis of the design itself, considering, like budget and failure modes, which take all the components of our given design, and analyzing them and seeing how they could each fail, thus leading us to coming up with a test plan to avoid such failures. So in our design analysis, we ran through a failure analysis, which took the components, as I said, from the treadmill in our design overall view, being the light gate system, motor, treadmill, etc., and ran through this analysis of design failure mode effect on the user, which allowed us to compute a risk priority number that comes from the product of severity, occurrence, and detection. This risk priority number allows us to see and be informed on which failures could be at highest risk for the user. As you can see here, the light gate system itself ranks pretty high with a value of 50 due to its liability needed in this product, as well as the power supply, because without that, it could not run and sufficient therapy could not be received. From this, we can now go on to our presenting our top 3 designs.
The 3 designs we have to present to the client to choose from for the team to move forward with is our retrofitted woodway design, which is our most robust but our most expensive design alternative. Our tiled traditional treadmill design, which is our least expensive alternative but poses the shortest lifespan. And then finally, we're going to present the possibility of a custom treadmill design, which would best fit NeuroHope's constraints, but may pose a difficulty in meeting the safety standards required. We've had the opportunity and privilege of getting in contact with Woodway Treadmills, which are the leading designer of slatted design treadmills. We have been given an offer of a certified refurbished treadmill that would usually be priced at around $7,000 and has been offered to us at just $2,650, including shipping. The benefits of this Woodway treadmill come with the name. You can be sure that a Woodway treadmill will already be built and maintained to safety standards. Plus, the team understands that the design of this treadmill is going to make it very easy for us to implement our replaceable tread designs onto the slats. Cons in this design are that it's obviously over budget at $3,215, and additionally, we're worried about the placement of the light gate on this design. When we first got the dimensions of the treadmill that was offered to us, we realized that the light gate will likely not be able to fit around either sides of the treadmill, but the team has already been working on plans where the light gate could be wheeled up onto the top surface of the treadmill with wheels being locked into place on either side of the running surface or walking surface. That way, the user can still have the light gate remaining stable and locked into place, and they can still feel safe while using the treadmill. Additionally, we understand that the Velcro will wear out over time, and that is something that we need to look into and could cause a shorter lifespan of this product. The cost breakdown of this design is, like I said, a Woodway Desmo Pro given to us at a fantastic certified refurbished cost of $2,650 compared to the usual refurbished cost of $7,000. We're allotting $75 for Velcro. We have found turf that we believe meets NeuroHub specification as described in the material selection at around $90. And like I said, we're looking to do more research into foams, and we're hoping to find a cheaper foam alternative that could bring our cost estimate on the foam down below $300 and bring our overall total cost estimate down as well. Finally, we have a miscellaneous cost, which is $100 towards adhesives and other things to apply the Velcro and tread alternatives to the slats of the Woodway. We'll now move into our tile traditional treadmill alternative.
So with our tile traditional treadmill alternative, we would be taking a traditional treadmill opposed to a Woodway treadmill. And this would leave the traditional tread on the treadmill itself, and Velcro would be placed down with adhesive to fasten the different tread types onto this treadmill. The tread itself would be composed of different mini tiles like the Woodway, but with this design, the dimensions of the traditional treadmill would not allow for the light gate to fit around it. So similar to the Woodway Velcro, it would need to be sewed on top and fastened to the sides of that walkway there, or through retrofitting and modifying, we can make the light gate fit around this treadmill, but that would take away from the width of the tread itself. This alternative design is obviously least expensive due to the fact that it wouldn't be a huge name brand treadmill like the Woodway, and also the Velcro, as Tyler mentioned, would wear over time. So again, something we would have to look into. The cost breakdown here uses the same Velcro, foam, and turf due to our idea of a universal purchase in bulk, because these materials would not come to specifically fit the dimensions of our tread and treadmills. So buying in bulk would allow us to then hinder and tinker with these different materials to allow it to fit our treadmill specifically. But the significant reduction of cost comes from the treadmill being $1,400 opposed to the Woodway, which was $2,650. So we have a total of $1,965. From this, we can now present to you our custom treadmill.
So our custom treadmill has several pros. It's best fit to our clients' constraints. It's also under budget, and the longevity of this product is more likely to outlast the other two designs. We have several cons for this product though, some of which we're making this from raw materials. We will also be lacking the knowledge of building a treadmill, for none of us have ever built a treadmill, but we do have a reference who is our lab manager, James Emery, who has spent a little time on working on treadmills. It's also the most complex design that we have, so we would have to do a lot more of thinking on this and building. We'd also have to meet safety regulations on this treadmill if we do go this route. And then we'd also have it's the hardest manufacturing, and it's the most time consuming. So the part with the COVID cases rising, our time in the shop would have to be higher. So if there is a spike where we're not able to meet, this would cause a concern. And then the overall price would be $2,390. And then the cost breakdown for this is we'd be having to buy bearings and brackets, base framing for this, plastic blocks for the slats, the motor, electronics, nuts and bolts, a track belt, a drive belt, and then the universal foam and turf, and then also shipping costs for some of those items. And then that's.
So through failure analysis of our designs, we broke the components of each 3 designs up. For example, the motor, tread, the tread attachability. We broke these up into different components, and we rated and looked at the possible modes of failure. We rated them based on the ability to detect severity, frequency, and we graded them and looked at which components were most likely to fail and how severe they were on the system. So from there, we gathered which components we need to really focus on and really test on. And we threw in hypothetical diagrams of how components could fail. And as you can see, for example, the user is unable to walk on a treadmill. You can look at why the treadmill isn't running. It could be a multitude of things. So this puts in the aspect of, say, the user, Neurohope in this situation, and allowed us to look at the technical writing standpoint of how we could answer frequently asked questions or how we could stop these modes of failure. This allowed us to come up with a test plan that would ensure we test every component to the highest extent and allow us to essentially inhibit any failure before it happens. And if this failure were to happen, the easiest possible way it could be overcome and the best solution.
With that being said, once the design has been decided on, the team is excited to move forward with purchasing the required materials and then constructing the treadmill. And then we can go through with testing that treadmill based on the test plan that D'Angelo just described to ensure it meets all of the safety, user, and structural standards that we hope it to meet. So we'd now like to take it to Derek to talk about our team management.
So in the in the top left, we're going to be going through our responsibility assignment matrices. And in the top left, this was right after gate review 1, I made this. So the highlighted, you can see test plan and budget plan that Jacob was assigned to both of or responsible for both of these. And through later discussions and meetings with the team and getting to the final product, on the bottom right, we can see that the test plan, I ended up taking that role, and then Jacob was on the budget plan with help from D'Angelo. So this is a very modular way of assigning people to tasks and being flexible with people. And if people don't have enough time to finish something, other people can pick up on that. And we keep the team members up to date through reminders as well as update messages on each one of these project components.
So we'd now like to open up the presentation to a discussion between faculty members and our client. And we'd like to see if the client would like to make an informed decision of what treadmill design they would like the team to move forward with today.
Well, that's not actually your job to say. That's my job to say. So okay. I appreciate if I'm allowed to do that. I have some questions first for the team. I think you know which questions are coming, yes?
Yes.
Yes.
Okay. So let's ask some questions here. And I think we'll go with, how about order Nolan, Rayner, Rorig, Ilham, Burton? Does that sound good?
Yeah.
Sounds good.
Okay. So I want you to communicate to the client design functionality you developed.
So the design functionality that I developed was when we were looking at the Woodway treadmill and we saw that we were worried about the light gate fitting on either side of the treadmill. I designed the design functionality that the light gate could be placed on top of the treadmill and we could have a mechanism to lock that light gate into place to maintain the stability and the safety of the user.
So functionality I developed was a part of our Velcro treadmill. It is the tiled aspect of the turf or the foam. I developed that with a sense that we would need a larger roller diameter in order to make that possible.
I came up with the functionality of a slatted track where we could actually make a hard plastic casing and then a insert where we could adhesive or put on a foam or turf onto the slide itself. And these would make for an easy transfer, but it also make for a longer longevity of the product.
Then I had the idea of extending the motor from a traditional treadmill further out in front to allow for more clearance of our foam or turf.
And then I came up with the design alternative of the traditional Velcro, the idea of using a traditional treadmill opposed to the woodway, as well as using Velcro as the fastening mechanism.
Okay, so that was like 3 things. I'm asking for one specific thing. So can you just roll back and give me one specific thing?
Yeah, I had the idea of using the traditional treadmill for that specific design.
And that design what?
The traditional Velcro design that we presented.
Okay, thank you, gentlemen. I appreciate that. Okay, I want you to describe your contribution to the project. Nolan Rayner, Rorig, Elon Burton.
So my contribution to the project was ensuring that the team was telling a story through the diagram presented here in the presentation and keeping the slides organized.
My contribution was creating our Ishikawa and failure mode effect analysis diagrams, a part of our failure analysis.
My contribution was making the budget plan as well as making the CAD drawings that you could have a visual for.
And mine was organizing team meetings, assigning roles, and making sure everything gets done on time.
Mine was the bulk of the failure analysis, as well as some components of the design analysis like budget.
Okay. Sounds pretty good. So let's ask some other general questions here. I want to know what your team's unsure of at this time.
I think one thing we're unsure of, like we talked about with material selection, is we're still a little unsure as to what foam we're wanting to purchase. We found some very expensive foams that meet our properties, but we're unsure if that's the only option. We're hoping to find some other foam alternatives that still have the needed material properties at a lower cost.
What else?
Also, we're unsure of if the client does go with the Velcro traditional treadmill, we're unsure of which treadmill we'd select for that design.
Okay. What else?
Given the traditional treadmill, as Derek mentioned, we are unsure of how we would go about extending that motor to allow for different thicknesses of tread, such as the foam, to allow clearance for that to not cause any problem.
Excellent. I like the fact that multiple people have thought about this. This is good. Okay. What resources do you need to be successful and get your view 3?
We're going to be needing to stay in close contact with James Emery in the shop to make sure that we have all our designs through him and that everything is feasible and made to spec.
And also Dr. Sakib to help us with more material selection and different force calculations for Velcro and other elements of our treadmill.
Any other resources you're going to need?
I think it's important to stay in close contact with Mr. Rishwalski and NeuroHope to make sure that our overall view of the project stays on track. We need to keep in mind that we're making a treadmill that is going to be used by real people and help with the rehabilitation process.
Yes, I think that's very important. Okay, I think you described your time management methodology pretty adequately. Well, let's talk about some requirements here. I think I messed up these questions here. So let's talk about a design functionality that you ranked high, the client didn't consider? Tell me about that.
One thing we ranked highly was the longevity of the treadmill, and I don't believe our client like ever really thought about that.
Okay. Okay. And how about a design functionality that that you jettisoned? Can you tell me something about that?
One thing was like the budget. Getting a Woodway treadmill for a fifth of the cost would be something pretty big, and that would allow us to have as high foam height or tread height in our foam and turf.
Okay. Okay. Well, let's give these guys a round of applause, and we'll open up to questions from general questions. Let's give a round of applause for these guys. These guys are doing well. Yeah. Okay, so now let's open up the floor for general questions and questions from the client.
All right, I'll start if anybody else doesn't have any other questions. All right, so can you guys go back to the screen that has the 3 treadmills, your 3 designs? Yep, thank you. Talking about the custom, I think when you were doing the financial breakdown, did you guys consider also the controller as part of the budget for that? Because I didn't see anything in there.
Yes, that was in the electronics area.
Oh, okay.
Electronics. So we more than likely will be able to use the electronics out of the treadmill we already have and adapt them to fit this custom built treadmill.
Okay. Along with that, since I talked about this one, with it being a custom treadmill, there's already no safety ratings involved in it. Is there any way to go about getting it certified for work being used in a medical facility?
We need to do a lot more research on that specific area. This was a new design that we just got relevantly new to us. But from the limited time that we had, I was able to do a small amount of research and figure out that most of the things that we will have to do is basically cover the areas where there's moving parts, such as where the bearings are, and then also on the edges of the treadmill where it will be moving from against plastics. So you cannot wedge a finger or toe or something into that area. And it cannot get caught on clothing. Then also we will have to make warning labels and then also incorporate a emergency stop sequence in it.
Perfect. Okay. And will that also include a weight rating?
Yes. So we did a little, I talked to James Emery about the weight rating on this. So on our framing, we're going to go more than likely going to go with an aluminum design for it's cheap and sturdy. And then also for the framing of the plastic blocks, we will be making it into a T-shaped configuration for that it won't bend as easily and it will not give away the weight.
Mm-hmm. Okay. With the traditional and the Woodway treadmill, you talked about creating a platform along the side so the light gate can roll up onto it. Is there I mean, they both sit fairly high. I'm assuming you have some kind of design for a ramp that would lead up onto the treadmill?
Yes.
That is correct. You can see here on our retrofitted Woodway, we're also putting railings inside, and then also for the tile traditional, there's kind of 2 directions we can go here. If we want to maintain the specified width of the walking surface, which I believe was 20 or 22 inches, we are going to have to put the light gate up on the platform. But we have figured if we can get the constraint if we can reduce the constraint on that walking surface, we believe we can have the light gate staying on the floor on that stable surface.
Okay. Awesome. And then the last thing I have that I wrote down was, I believe at least 2 of the designs include Velcro. And I don't know much about Velcro. I know there's more out there than one design, but talking our population and the fact that our clients can't necessarily pick up their feet that well, which is the purpose of this treadmill. What would the longevity of the Velcro be if we have clients constantly dragging their feet and pulling on that Velcro?
So the longevity of Velcro, just peeling and putting it back on, is about 20,000 times, which I like equated to about 7 years. But if they're like dragging their feet on it, it would probably be closer to like 2 to 3 years. So we would probably implement a way to like easily replace the Velcro in order for it to be like used for a longer period of time.
Okay, so would you, when you're talking replace the Velcro, are you talking just the Velcro and whatever mediums on top, or be able to just replace the Velcro on that, foam or turf?
Yeah, we would have to do more research on like what is the failure on the Velcro, because if it's either the hooks or the loops of the Velcro, so like the fuzzy part is the loops and the hooks is the hard part of Velcro. So if it's the failure is more in the loops, we would be able to put that on either the top or the bottom, and then we'd be able to just replace that part. And if it's the hooks, we would do it the same way. And if it's both, well, we would have to, do both of them.
Right.
But
okay.
Yeah, we would need to do more research on that.
Sure. Yeah, no, that sounds great. That's all I have.
Hey, let's keep these questions up. Other questions for our team right now?
Question, guys, that kind of stems off of that last conversation. So you have some things that you're unsure of going forward, and your client has now asked for a couple of more investigations. Do you have a testing plan going forward of, these uncertainties and what you're thinking about doing before you make final decisions?
Yeah, if you want to go down to the test plan, like down. Yeah, so here's our test plan. We have some Velcro slipping, Velcro not sticking, and we would go through and test all of these different things. And then also we have like foam density and foam thickness to test different types of foam. And like if one of our foams doesn't work, we would do a better calculation to find do more calculations to find a better foam. And then that's about that.
Okay.
No, great. And then in addition to that, so with your 3 designs, I can see, where you've kind of deviated and looked into different aspects of it. My one question is, and this is exactly the slide I was hoping you'd go to, how are you going to be interchanging your different surfaces? Is everything going to be Velcro? Because you really only talked about the Velcro for the tiled traditional design.
So no, that's not the only way that we have it attaching. So on the custom treadmill, which I believe we would be able to find a way to incorporate it into the other 2, it's a sliding mechanism where one end is open on this plastic, and then it's grooved out, so you can slide a second plastic piece into it. And so with that sliding into the second piece, that second piece would also have the turf or the foam on it. This way, that would last longer than a Velcro.
Okay, so that's like an alternative subsystem idea.
Yes.
And that's in your custom treadmill.
Yes.
Okay.
It could also be put into the Woodway Velcro, but we would have to do more research on like how they build their different slats, and if we could be able to like modify those slats to allow us to stick things in while it like still holds on to it.
Otherwise, you were going to go with the Velcro option of adhesive to the current slats on the woodway.
Yeah.
Okay. Thank you.
Other questions?
So on the same page, here I see that you say the custom treadmill is the best fit to constraints. But you didn't say that for other treadmills. What are those constraints here and why those others are not the best fit to the constraints?
So the constraints on the custom treadmill that it's best fitting is the width of the tread that the patient's going to be walking on, and also the overall width of the treadmill for the light gate to fit over. Mm-hmm. So on the tiled traditional, we have two options where we can rather accompany to just the tread width or the overall width. And then for the woodway, the constraint on this is it is too wide for the light gate system, but it has the length of the width that it needs. So we'd have to do a little bit more research on getting it up onto this platform and then locking it into place and looking into different options for or the safest options for locking the light gate into place on this.
Okay, thank you.
We also figured that through our estimates that it would stay under the $3,000 budget constraint. So that's also a big constraint. It stays under compared to say the woodway, just slightly over.
Right, so the cost is also here as well. Okay. Thank you.
Okay. Other questions? Okay, so my question for the client is, has the team presented 3 designs so far to your satisfaction? Do you feel you could move forward with one?
Yes, I think they've given me 3 great options. I don't think I can decide right now. I would have to talk it over with a few colleagues, but I do believe that one of these will do just fine.
Okay, that's good enough for me. What I would strongly suggest at this juncture, team, if you want to take a sidebar with your faculty, if they could for a few minutes, if it's even possible, if they're not booked, maybe get one of them, get the client, and talk a little bit more. Do you have a little time, esteemed guest?
Unfortunately, I have to go right back into work right now.
Okay.
I did send Tyler an email about getting set up later, maybe this evening or tomorrow.
Okay, sounds good. Let's give this team another round of applause, please. Let's give them a round of applause. Okay, good job. I'm going to stop this recording. Okay.